Hey guys, we're going to do badge 6. So what makes this badge 6? Notice that we have an X bar, right? And that means we have actual numbers, not yeses and nos. So that's why we're in the 5, 6, 7, and 8 range, right? I also want to change this because I don't want to get into having to address creating dot plots, right? So I'm going to assume that this problem is exactly the same, but that they gave us 30 children data and 30 adult pieces of data, and that from this data, this was the numbers, right? This was the standard deviation of the children, 30 children, and this was the standard deviation and the average from the data collected on 30 adults, all right? So, how do I know it's a badge 6? Excuse me. It's because we're doing a confidence interval. So badge 5 and badge 6 are confidence interval. 7 and 8 are doing a test. So let's get to it. It says researchers studying the learning of speech often compare measurements made from the recorded speeches of adults and children. One variable of interest is called the voice onset time. Here are the results for 6-year-olds and adults that pronounce the word bees. The VOT measures in milliseconds and can be either positive or negative. All right, so imagine there would be some use for being able to see the age of a person or whether you're young or old from a voice activation, right? From some voice recognition, right? The researchers were investigating, so this is what we're investigating, right? Whether or not VOTs can be distinguished from adult children. So I don't see them wanting one way or another. They're just saying, are they different from each other? So let's get to our state, right? Our state would be, we will estimate, because a confidence interval is an estimate. We will estimate mu1 minus mu2. So just like badge 5, we were estimating mu. Badge 6, we're just doing it with 2 groups, right? What is mu1 minus mu2? True difference in, and instead of the word proportion, I'm using the word mean. The difference in mean, VOT, when pronouncing the word bees, right? All right, so let's get to our plan. All right, we don't hear them. So we're going to say, assume that the children and the adults were chosen randomly. All right, and 10 yeses and nos? No, that doesn't make sense. But notice how I changed the problem to 30, so we can say our sampling distribution shuns both of our sampling distributions are approximately normal because the central limit theorem, because N1, which is 30, is greater than 30, and because our second sample size of 30 is also greater than 30. Okay, what about independence? We should have independence because our population of children should be greater than the sample size times 10, right? And our population of adults, there's more than 300 children in the world and more than 300 adults, right? State plan do. So what is our general formula? Well, we have to remind ourselves we're doing a confidence interval. So point estimate, margin of error. So what is our point estimate here? We normally would say, is there a difference of proportion? But we're like, whoop, wait, rewind. We've got X bars, right? Not proportions. So we want to say X bar 1 minus X bar 2 is our point estimate. And it's plus or minus. Instead of Z, it's T star, right? Now, what is the standard deviation of 2 things? Well, we always have to add variances. So it's our standard deviation squared, since we square variances, and our standard deviation, the second one, squared over our second population. All right. We also want to address, we would look this up in the table, our degree of freedom would be n minus 1. So if we have 30, we would look for 29 on the margin, right? And it says 95, so we float up from 95. Appears we get the number 2045, all right? So let's type this in our calculators. Oh, my calculator's trying to crap out on me. Let's hurry, see if we can get this done before it decides to give out. So we go menu, stats. Now we're going to confidence interval, right? And we have a two sample t interval. And we have our data already. So what is our data? We have the statistical summaries already given to us. X bar 1 is negative 3.67. Our standard deviation is 33.89. How many people? We change that to 30, right? All right, let's see. In our second group, we have negative 2317, and our standard deviation, 5074, and we talk to 30 adults. Our confidence level is 95, and we're going to say no to the pool. Okay, so we're going to hit OK. And what do we got here, right? We got a C lower, a C upper. Yep, so we're going to take a picture of that screen and take it back to our notes. All right, so we go to our notes here. Just crop this down. Got a little bit of a reflection there, but hopefully we can still see our numbers. Yeah, okay. So we have a lower, it's kind of hard to see. It says negative 2869, yeah, and an upper. And we say, ooh, this is interesting, guys. It says, is there a difference? Yes. The difference is 19. And that makes sense. When I subtract negative 367 from negative 2317, there is a difference of 19, right? So we get 19.5. Might be easier to put it here, 19.5, plus or minus our margin of error, 22.4. So our calculator gave us an interval, negative 2.86 and 41.9. I usually round. You don't have to, though. You guys know that. All right. Hopefully that doesn't throw anybody off. All right. So they asked us to create an interval, and we did. So when we conclude, we can say we are 95% confident that the interval from C lower to C upper captures the true difference. We have a difference in proportion. I'm back to, no, not proportion, difference in means. This is a means question. They're not asking yes or no's. They're asking a number, right? We're measuring something. Difference in the means, VOT, between children and adults when saying the word bees. Now, are we done? Well, the challenge was if we weren't done in badge 2, remember we weren't done in badge 2 because we have to look for the 0. So if we weren't done in badge 2, we're not going to be done in badge 6 because we're doing the exact same thing. We're just doing it with a means question and not a proportion. Okay. So we notice that 0 is in here. So let's be very precise at what we're doing. We notice that 0, gotta fill that in, is in there. So let's think very specifically about what that means here for us. we'd like to conclude that there is a difference. We'd like to conclude that VOT does distinguish between adults and children, but it doesn't look like it does. So we're going to say, because 0 is in the interval, we can't make the conclusion that the researchers want to make. We can't conclude that there is a difference in VOT levels, right? Between adults and kids. Thanks for joining us, guys. Again, this is for Badge 6.